Hello friends, this is part 3 of mathematical physics paper solution, third semester CBCS paper C-5 2023. So today we're gonna solve these two questions. Question number 3D, we're gonna prove these two relations. Okay, so let me show you this one first. The first relation, we are going to prove this relation. Okay, so how to prove this? First, let me take the first recurrence formula of Legendre polynomials. Hope you have watched the video where I have proved all the 6 recurrence formula of Legendre polynomials. So if you haven't watched that video, then link is in the description box. Please do watch that video. Okay, so the first recurrence formula was this: nPn of x is equal to twice n minus 1 into x pn minus 1 of x minus n minus 1 pn minus 2. That was the first, right? Now what we are going to do now in this case, so first what we're going to do, first let me bring this term to this side. First let me write this term on this side. Just give me a second. Okay, so what I have done, that I have assumed that I have kept this term on the same side. I have brought this term to this side. Okay, so then on the left hand side, nPn, so whatever I should get on left hand side, I have written on right hand side. Okay, and whatever be the term, the term which should be on the right hand side, I have written on the left hand side. That's it. Okay, I have switched the side only. Okay, this term is brought to this side, plus n minus 1 p n minus 2. That's what I have done. So I have rearranged the terms, as simple as that. So here you say, let me make it n plus n. So how to make that? Just replace n by n plus 1, replacing n by n plus 1. Then what we're gonna have? So here you see, here if we put n plus 1, then 2 into n plus 1, that will be 2 into n plus 2, right? Then here we have minus 1, so minus 1, that's gonna give you 2n plus 1, right? That's gonna give you 2n plus 1. Okay, if you replace this n by n plus 1, right? Hope you have understood this. X p, here we had n minus 1. If you replace the n by n plus 1, then here minus, so minus 1 plus 1 gone, so we're gonna have here pn. So here pn of x, right? Hope you have understood this. Similarly, this n will be n plus 1, n into n plus 1 into pn plus 1 of x, right, of x, plus this n is replaced by n plus 1, then we have minus 1 here, so plus minus gone, so that's why it's gonna be n. Then here if you replace this by n plus 1, then plus 1 minus 2, that's gonna give you minus 1, so n minus 1. So here we're gonna have n into pn minus 1. That's what we're gonna have, right, of x. Okay, hope you have understood this. Now what I'm gonna do, let me take the left hand side of this relation that we need to prove. So first let me take the left hand side. What was the left hand side? Minus 1, integration from minus 1 to plus 1. Okay, let me copy this. Just okay, this is what we have, right? So now integration from minus 1 to plus 1. So what I'm going to do here, I'm going to replace this x into p and x by value of this, just give me a second. So we can divide this equation, both side of this equation, by this coefficient, right? Let me do one more thing. We can divide it by twice n plus 1, twice n plus 1, twice n plus 1. Then what we're gonna have, we're gonna end up getting this. Just let me show you. So here this 2n plus 1 will be cancelled. Then here we're gonna have n plus 1 by twice n plus 1, right, into p n plus 1 of x. Then here we're gonna have plus n by twice n plus 1 into this. That's what we're gonna have, right? So let me take this as equation number 1, and from 1 we're gonna replace this value of this by this result. Okay, so if we do that, what we're gonna have on the left side, just give me a second. So here we're gonna put this value here, right, x into this, then pn minus 1 of x dx, right? That's what we're gonna have. So let me copy this last step and let me go to a new slide. Okay, so here is the last step. Okay, so now what we can do here, so integration here, you see, I think this x should not be here. Let me tell you why. Let me go back to the previous slide. So actually we are replacing this x pn, right? So that's why this x should not be here. Okay, hope you have got it. Okay, so that's why now let me open this bracket to integrate this. So doing so, what we're gonna have, n plus 1 twice n plus 1 p, this is, there is integration, constant term is taken outside, pn plus 1 of x into this pn minus 1 of x dx, right? That's what we're gonna have, and plus n into twice n plus 1 integration from minus 1 to plus 1, from minus 1 to plus 1, and then if you multiply this one and this one, then what you're gonna have, you're gonna have pn minus 1 of x whole square dx, right? That's what we're gonna have. Now you see, if we apply the orthogonal property here, you see, what was the orthogonal property for Legendre polynomial? That was here you see the property was minus 1 plus 1 pm of x into pn of x dx is equal to 0, provided n is not equal to m, right? So here you see n plus 1 is not equal to n minus 1, so that's why this part must be equal to 0. We can consider this one as m, this one as n, right? Hope you have understood this. So since this is equal to 0, so we can write, let me write this way, by orthogonal or by orthogonality of Legendre polynomial, p of x, what we're going to have, integration from minus infinity to plus infinity, this part going to be equal to 0. So let me write this one here, just give me a second. That's going to be equal to 0, right? So this part becomes 0. So now we end up getting left hand side, which is this was the left hand side, right? This is equal to, we have only this part, now, because this part is 0, so we're gonna write this part only. So that is n by twice n plus 1 integration -1 to +1 pn minus 1 of x whole square dx, right? So let me copy this and let me go to a new slide. So here is the new slide. So now you see, we also know, let me write this one, equation number 1. Okay, sorry, not equation 1 we have already used, I think. Okay, let me see. Yeah, here using 1. So we have already used equation number 1. So let me give it equation number 2. So let me take this one as equation number 2. Now you see, we know this relation. If you don't know, then I've given a link in the description box. Please do watch that video. Okay, I have given 2 links, one for the recurrence formula and another for this formula, that is integration from -1 to +1 pn of x whole square dx is equal to that formula was 2 by twice n plus 1. Okay, we must know this in order to prove this. Okay, so now here you see, if we replace this n by n minus 1, then you're gonna get this, right? So let's replace n by n minus 1. Then what we're gonna have? Then we're gonna have integration from -1 to +1. So here let me replace, just I have written, it should be like this, replace, yeah, that's fine. Okay, replace this n by n minus 1 p n minus 1 of x whole square dx. On the other side, 2 divided by 2, instead of this n we're going to write n minus 1 plus 1, right? Now if we simplify this, what we're going to have? 2 divided by twice n minus 2 plus 1. 2 divided by twice n minus 2 plus 1, that's going to be -1. So let me use this equation number 3 in 2, using 3 into. So using 3 into, therefore let me go to the next slide. Just let me copy the equation number 2 and 3. Okay, let me copy this equation number 2 and paste here, and let me equation number 3, let me copy this equation number 3 and let me paste here. Okay, so using 3 into, what we get? So the left hand side, which is equal to this one, so let me copy this, which gives this is equal to, so now n by twice n plus 1. Now replace this by this result. Okay, we're gonna put this one here. Okay, this one is nothing but this one, right? Hope you have understood this. So then 2 by n minus 1, right? So now you see, if you multiply this, then what you're gonna have? 2 into n twice n, and if you apply a plus b into a minus b, then you're gonna have 2n whole square. That means 4n square. You can write 4n square minus 1 square is 1 square is 1, right? So this is the right hand side. So here you see, that's proved. So this one was the left hand side, right? Hence proved. Okay, this is what we needed to prove. Let me go back to the question again. Let me show you what we needed to prove. This one, here you see, this is the result that we have got. Sorry, here you see. Hope you have understood this. Now let me take the next relation. Now let us prove this relation. Okay, so here is the relation that we have to prove here. Okay, how to prove this? Okay, now you see, So we know the Hermite differential equation. Hermite differential equation is of this form. That is second order derivative of y with respect to x minus twice x into first order derivative of y with respect to x plus twice n y is equal to 0. We know this, right? So this is suppose equation number 1. Now if we consider two Hermite polynomials, suppose h m of x and h n of x are the Hermite polynomials, then they must satisfy the equation number 1, right? That means this is solution of this equation, this must be also solution of this equation, right? Hope you have understood this. So if they satisfy equation number 1, then we can obtain two relations. For the first one, if you replace the y by this polynomial, then what you're going to have, hm of x, second order derivative of hm of x, right? Then minus 2x, then first order derivative of hm of x, then plus twice n into y is replaced by hm of x is equal to 0, right? Similarly, we will get similarly this polynomial also must satisfy this equation. So for that polynomial, we're going to have equation of this form. Instead of hm, we're going to have hn. Let me replace the m by n here. So here, second order differential equation of hn, second order differential derivative of hn. Here second order derivative, first order derivative of hn, and here for hn of x. So these two equations we're going to obtain. This is equation number 2 and this is suppose equation number 3, right? Hope you got it. Now let us multiply equation number 1. Equation number 1, let us multiply it by e to the power minus x square. Okay, so then what we're gonna have, let me, not equation number 1, actually it's supposed to be equation number 2. Let me copy the equation number 2 and let me write this equation here. Okay, so what we're gonna do here, we're gonna multiply e to the power we're going to multiply e to the power minus x square, and here also we're going to multiply e to the power minus x square, e to the power minus x square, and with the first term as well. Just give me a second. E to the power minus x square. So let's multiply this. So now what we're going to have here, so we can transfer these two on the other side, right? So then what we're going to have, you see, if we transfer this term to the other side of the equal sign, then this positive term will be negative, right? Here it will be negative, so we can write this way, this is equal to this, right? Hope you have understood this. Now here you see, let me write it properly, just give me a second. Okay, so e to the power, let me write it properly, e to the power minus x square. Now this part can be written this way, ddx of e to the power minus x square into hm of x, right? Well, let me explain. So here if you apply the product rule of derivative u into v. Okay, so this is u, sorry, it's supposed to be h dash of m, hm of x, sorry, first order derivative of hm of x. So now you see here, if you consider this one as u, e is the first function, e to the power minus x square is the first function, and hm as the second function, hm this is the second function. Then first function derivative of second function, if you differentiate this again, then we're gonna have second order derivative of hm this hm. So similarly, in the next term, this second function, this is hm dash, derivative of the first function, derivative of this e to the power minus twice x is this, right? Hope you have understood this. So we have used the product rule, that is ddx of u into v rule. Okay, hope you have understood this. Similarly, from equation number 3, if we multiply e to the power minus twice x, e to the power minus x square on both sides of equation number 3, then also we can obtain this. That similarly, let me write similarly. We don't need to show it again because procedure is same, so we can write similarly. We can obtain ddx of e to the power minus x square hn of x, okay, this is equal to minus 2n e to the power minus x square hn of x. That's what we're gonna have. Now let me copy this last two results and let me go to a new slide. So here is the last two results. Let me write. Okay, so this is what we have got, right? So we have got these two results. Okay, so now what we can do here, you see, we're gonna multiply hn of x on the both side of this equation and hm of x on this on the both side of this equation, right? So first, okay, let me continue here. Okay, what are we gonna do here? Let me multiply hn of x on the right hand side as well as left hand side. Okay, as well as left hand side. So then what we're gonna have is n of x, then here we're gonna get this, let me write this one properly, just give me a second. Okay, right. Okay, one more second. So this is what we're gonna have. Let me show you. Okay, so now hn of x into this, let me write it properly. Okay, so this is what we have got. Okay, hope you have understood this, right? Similarly, on the other side, we're going to multiply hm of x. We're going to multiply this term on both sides of this equation, right? Okay, let me copy this and paste here. Okay, so similarly on the other side also we're going to multiply hm of x into this term. Here you see this one. So we don't have enough space here. Let me rearrange the term. Okay, hope you got it. So this is what we have got. Okay, right? Hope you have understood this. So now what we can do here, you see, this is suppose equation number 4 and this is suppose equation number 5. Okay, now let me subtract 5 from 4. Okay, equation number 4 minus equation number 5. So left hand side minus left hand side. First let me copy the left hand side of equation number 4. Here is the left hand side of equation number 4 minus the left hand side of equation number 5. Let me copy that. Here is the left hand side of that, and on the right, on the other side, let me take the right hand side of equation number 4. Okay, then minus right hand side of equation number 5. So this is how we can do, right? Hope you have understood this. Now we're going to integrate both sides from minus infinity to plus infinity. Okay, so let me integrate. So before we integrate, let me simplify these equations. Okay, so here you see, okay, one more important thing I forgot to tell you. Let me go back to the previous slide. So now you see, when you use m here, okay, then instead of n here, let me write twice, instead of twice n, let me write twice m. Okay, and we can keep twice n here because here we are using m. Okay, so in that case, here this equation, here you see this, instead of this n we're gonna write m. Okay, here we're gonna keep it n. Just hope you have understood this. So here this is twice m. Okay, so if that is the case, then here you see this minus twice n should be twice m, right? Here also we should get twice m, minus twice m. Okay, now it's clear. So it's supposed to be minus twice m. So now you see what are the terms can be taken common here. You see minus twice m minus twice n. Now here hn of x, hm of x, e to the power minus twice x, that can be taken common. Even 2 can be taken common. Let me take that 2 as well. So we can take 2 into e to the power minus x square, hm of x into hn of x. You can take that common, right? Hope you have understood this. So now this part here, minus minus plus, so we can make it n. We can make it minus m plus n. That means we can write n minus m. That means we can write n minus m, right? N minus m into this, right? Hope you have understood this. Okay, now let me integrate. Integrating, what we can do, let me copy this left hand side first. So here is the left hand side. So let's integrate it from minus infinity to plus infinity. So we're going to integrate this whole thing. So here we need a square bracket. So let me use here curl bracket. Within square bracket, let me use curl bracket. Okay, so here let me use the curl bracket. Okay, so square bracket dx. So on the right hand side, integration from minus infinity to plus infinity, 2 into n minus m, 2 into n minus m, e to the power minus x square, hm of x, hn of x, hn of x dx. That's what we're gonna have. Now let me copy this step and let me take a new slide. Okay, so so here is the new slide. Okay, this is what we have got. Now if you consider the integration of this part, right? If you consider the integration of this part, integration, now let me integrate this part. Okay, e to the power minus x square, hm, okay, dx. This is what we're gonna have, right? So if we integrate, if we use it if we integrate this using integration by parts, then what we're going to have, first function, that is hn of x, and integration of second part, this part, that's going to be here derivative will be removed, so we're going to have e to the power minus x square, okay, hm dash of x, right? So integration from minus infinity to plus infinity minus integration from minus infinity to plus infinity, ddx of first function, that is ddx of derivative of hn, so that's going to be hn dash of x. Then we have the integration of second function, again integration of this part is again the e to the power minus x square, hm dash of x. Here we're going to put dx here, right? Hope you have understood this, dx, right? So that means we have used this rule, integration of u dv, that is u into v minus integration u dash v dv, right? Hope you have understood this. So this is what we have used. So here this is dv and this is u, right? Hope you have understood this. So now, yes, sorry, it's supposed to be dv here directly, okay. Now you see, from the second part of this same equation, from this part, what we're gonna have, let me show you. Okay, integration from minus infinity to plus infinity, right? Let me cut it. Integration from minus infinity to plus infinity of dx, this part here you see. So again we're going to consider as this one as u and this part as dv, okay. So then what we can write is m of x e to the power minus x square, then hn dash of x from minus infinity to plus infinity minus integration from minus infinity to plus infinity. So here hm dash of x e to the power minus x square, then hm dash of x dx. That's what we're gonna have, right? Now you see, these two parts gonna be equal, these two parts going to be equal to 0, okay, equal to 0, since here we can write that since e to the power minus x square, that tends to 0 when x tends to plus or minus infinity, because e to the power minus infinity is 0 and doesn't matter here the value of x is positive or negative. Here you see we have x square, so if you put positive infinity or negative infinity, in both cases that will be negative infinity. Actually x square, that if you put positive or negative infinity both, that's gonna give you positive infinity, and we have negative here, so that's gonna be negative at the end, right? So e to the power minus infinity is 0. If that is the case, then these two term will be 0, right? Hope you have understood this. So therefore you see, therefore this above equation number 6 will be of this form. So when we have integrated this, then we have got 0 minus this part. Here you see this part, sorry, let me copy this, just Just give me a second. Okay, we have got it, right? Then minus, when we have integrated this, 0 minus, but because of this minus, that's going to be plus this part. Okay, so here you see, actually it's supposed to be like this, right? Here it was minus, right? Because of this minus, if you open the bracket, this minus is going to be plus, right? Hope you have understood this. And on the right hand side, we're going to have this part here. You see, let me write it completely. Just give me a second. Let me rearrange these things properly so that I can have enough space. Sorry, just give me a second. Okay, so we're gonna have this. Let me copy the right hand side of equation number 6. So here is the right hand side of equation number 6, not completed yet. Just give me a second. So just one more second, right? Okay, let me write it properly. Okay, here is that. So here we have integration from minus infinity to plus infinity. This is from equation number 6, right? Hope you have understood this. Now here you see these two terms are exactly same. Actually, sorry, I made a mistake. This is supposed to be hn, not m. This is hn here, hn dash. This is hn dash. Okay, now here you see, this is hn of x e to the power minus x square, then hm dash of x. Similarly here, hm dash of x, hn dash of x e to the power minus x square, same term but in different order. So here it is positive, here it is negative, so we can cancel these two. So if we cancel these two from this equation, we're gonna get on the left hand side 0, and on the right hand side, let me keep the right hand side as it is. So that implies 0 is equal to this, right? Hope you have understood this. So we have got here 0, okay, as all the terms gone, they cancel each other. So we have got this. Now here you see, in the question it is already given that for m is equal to n, we need to show this. Sorry, m not equal to n. If m is not equal to n, then this part cannot be 0, right? So here this constant part can be written outside the integral. Let me show you. It can be written this way. Okay, now you see, that's why this term will become 0. It is only possible if this integral part is 0. Okay, since or you can write for m is not equal to n, the above, just give me a second, equation is correct if this integral part is 0, and this is what we need to prove, right? Hope you have understood this.